So we've made a lot of enhancements to our air conditioner and heat pump categories, and a lot of this work was done by a graduate student who was working here at NREL, Dylan Cutler. So he's the one who takes credit for a lot of this work. The first thing that I'll talk about is how we were able to simplify the amount of inputs that we require to model air conditioners and heat pumps. And one of the common support emails that we routinely get are, how do I add a new air conditioner BEopt? And previously there was no simple answer to that question. So this table that you see here are all the inputs that were required to model a new air conditioner in BEopt version 1.1. So there are lots of coefficients to biquadratic and quadratic curves, and once you could figure out what all this meant, you really needed to have a working knowledge of the models in order to figure out what exactly these coefficients mean. So what Dylan was able to do was to basically show that a lot of our modeling results are very insensitive to the curve coefficients that are assumed. And he used data from many different manufacturers, or from many different air conditioners across the leading manufacturers in the country, and developed a standardized set of curves for single speed, two-speed, and variable speed equipment. And now all those curves are basically in the background of BEopt, and now the user really only needs to enter in a very few number of inputs. So for a single-stage air conditioner, the user basically gets three different options, two of which need to be specified, and that can be either the SEER or the EER. And if they choose to enter in those two, BEopt will automatically calculate the cycling degradation coefficient. If the user were to know the cycling degradation coefficient and the EER, then BEopt would output the SEER. So we kind of given some flexibility in terms of what the user can enter. And I'll try to jump over here to the option editor screen. And so the basic inputs now include EER and SEER, and so and a lot of all the coefficients have basically been taken out of here. So it'll be a lot easier to add new air conditioners, or if you knew specific data about old ones, you could add that too pretty easily.
So just for those that are kind of new to BEopt, the screen that John's showing here is called the option editor within BEopt, and you can get here from the BEopt menu, or within a given category, if you right-click, there will be a pop-up menu that will give you the possibility to go to the option editor. And the option editor is where you can change properties. Well, you cannot change properties of the standard options that BEopt ships with, but you can make your own options, including the possibility to copy the properties of one of the shipped options and make a modified version of that, give it your own name for that option, and then change the properties. So the option editor is useful in making your own user-defined options. In some categories, that's very simple to do. In other categories, it can get a little bit complex. And one of the virtues of what John's showing here is that we have managed to take the air conditioner heat pump category, which used to be almost impossible to make user-defined options, into a situation that now it's quite doable. And so if you want to model a particular manufacturer's air conditioner and a particular model of that air conditioner, you can put the properties directly into BEopt and have a model within BEopt for that particular air conditioner.
It's also important to note that the inputs that are in this table are for single-speed air conditioners. And so for a two-stage air conditioner, the user would need to enter in the EER of the low and the high stage, and also the SHR as well, and as well as a capacity ratio that basically dictates the turn-down ratio of the compressor. So moving on to the next topic was when Dylan was going through a lot of this manufacturer data, one interesting thing that he discovered was that for high efficiency equipment, so we're talking about SEER 18 and SEER 21 air conditioners, that the rated SEER is highly affected by the nominal capacity of the air conditioner. And so you can see those trends on this plot. And so I have basically several product lines plotted here, two for the SEER 18 and two for SEER 21. And on the x-axis, we see what the rated SEER would be for a 2-ton, 3-ton, 4-ton, and 5-ton air conditioner. And you can clearly see how for the higher capacity units, the SEER goes down by a pretty large factor. And this was determined, this is basically due to a cost and size limitation on the outdoor unit, that, in order to get a SEER 21 5-ton air conditioner, the outdoor unit would need to be huge. And so there's a limitation there in terms of what people will buy. So we've gone ahead and included for the built-in BEopt air conditioners SEER D rating for the SEER 18 and SEER 21 units. And we basically have done that by including multipliers that are a function of the capacity. And so these red lines kind of denote what the built-in options are in BEopt and how the rated efficiency will go down with increasing size. And this kind of comes back to one of the other advantages of Manual J is that we can now do this kind of stuff. So there are built-in options in BEopt, and then the user can enter in specific product lines if they want to, and basically add a SEER 18 air conditioner and then change the D rate multipliers that are built in.
So the thing to remember here is that in BEopt, there aren't separate air conditioners with separate sizes. There's one air conditioner, and then, for example, the sizing is determined as John described with the Manual J-like methodology. And so these D rates are the way to take an air conditioner option and make it capacity specific. An interesting thing to note is that here the SEER 21 air conditioner, if you bought a 5-ton version of that, you get SEER 16 for what is nominally SEER 21. In fact, the manufacturers, these numbers are directly from the manufacturer's literature, and what one sees is that for that particular product line, the language typically is up to SEER 21, which that unit right there would in fact meet that, but at higher tonnage certainly not. And there's an interesting interaction then if you're make some efficiency improvements to your building and require smaller air conditioners, then you are in fact able to get high efficiency equipment, whereas if your loads are high, your only option, you could buy a couple 2-ton or 2.5-ton air conditioners. That'd be a pretty expensive approach, but it would be a way to get up into these higher SEER levels. So there's that trade-off between size and the actual SEER in these high efficiency units. For lower SEER units, this trend does not display itself.
And then just wrapping up with the air conditioner heat pump category, there are there are now a variable speed option for an air conditioner and a heat pump, and this is a SEER 24.5 air conditioner, and for the heat pump it's a SEER 22 HSPF 10. And so we've modeled this using data provided by a single manufacturer, and it's modeled using the performance at 4 different speeds, which the Energy Plus model definitely supports. So you'll see these options now in the options screen for the air conditioner and heat pump categories.